This video illustrates creating non-prismatic variation using LARSA 4D and the LARSA 4D section composer tool. Non-prismatic variation is the variation of section dimensions along the length of a member. It's created in Section Composer by applying formulas to shape parameters. Dimensions of a shape can be defined through parameters such as depth, width, thickness, angle, and more. To create prismatic shapes, numerical values are entered for their parameters. For non-prismatic variation, the parameters are given as formulas in terms of a special x variable. This variable represents the position along the length of a span. Non-prismatic variation can be applied to any section parameter in LARSA 4D. To simplify creating complex variation, multiple parameters can vary along the length of the member at the same time. In LARSA, we recommend defining the x variable between a value from 0 to 1, where 0.0 is the start of the span, and 1.0 is the end of the span. This is called relative position because it's relative to span length, which might not be known ahead of time or might vary from span to span. Alternatively, the variable may be at absolute length from the start of the span. The unit of length also depends on the unit chosen for the section in the Units window in the section menu. Formulas in terms of the special x variable can be assigned to parameters using LARSA's Parametric equation editor. It's accessed in the main menu dropdown for section and non-prismatic variation by clicking the function button available on the side of each parameter in the parameters list. LARSA's Parametric equation editor simplifies defining linear, Hanch, parabolic, and sinusoidal equations by specifying inputs like a value or slope at a specific point. If the full equation is available, custom equations can also be entered in the Parametric equation editor. Variation can be defined as a piecewise function within different ranges of length. In this example, a parabolic variation is defined for the depth of the section. As it can be seen from the alignment of this section, the member reference coordinate system is at the top face of the section. In the 3D model, it can be seen that the depth of the member varies as the member reference line is a straight line that connects the start and end joint of the member. When a section with non-prismatic variation is initially assigned to a member, the variation runs from the start of the member to the end of the member only. If there's more than one member, each member will be treated separately, and the x variable resets at the end of each member. Spans are used in LARSA to define non-prismatic variation when there are multiple analytical elements between the desired start and end variation points. The x variable does not reset at the ends of members within spans. As can be seen, the non-prismatic variation goes smoothly across the span. For sections with repeating dimensions, we can quickly create more than one span using the information available through LARSA's span spreadsheet. Once the information is open, we can use LARSA's graphical display to visually select the appropriate start and end point of the span and simply reverse its direction in the spreadsheet, as shown in this example. When working with these structures, The program's analysis engine and stress reports will explicitly take into account nonprismatic variation when a nonprismatic section is assigned to members or spans in a project. With these type of simple, powerful tools, the application of nonprismatic variation in LARSA enables the creation of complex geometries in a fast, effective manner. The variation equation can be defined for any parameter that a section has, including depth. In this next example, two width parameters are defined from the section centroid to the section side of positive z, and to the section side of negative z. By entering parabolic variation to both width parameters, a curved beam is quickly created. In this last example, piecewise Hansch is defined in LARSA's parametric equation editor. For this, we specify the start and end value of the width parameter, as well as for a span, which easily achieves increasing and decreasing width that we'll see. We hope you found this video for nonprismatic variation in LARSA 4D helpful, and welcome you to contact us at info@larsa4d.com for further information.